All right, I think we should be live. And if you saw my screen for a second there on Rotten Tomatoes reviews, we're actually going to use that for our fine-tune LLM a little bit later, which is why I had that up. Spoiler alert, what we're going to build, but I'm going to show you where we're going to build at the beginning anyway. And I know I'm a minute early, so people are still going to be rolling in here. As you're coming in, say hello in the chat. So this is live. I'm going to be monitoring the chat for all your questions, comments, etc. Say hello in there. Makes it definitely way more fun for me. Hopefully, I think more fun for you as well. I'll say hello real quick in there. Hello, and then, oops. I will share some links here in a minute. I'm going to wait for some more people to join in, but actually, I'll go ahead and share them. Well, I think there's several people here. I see Alexander. Hello, hello. How's it going? Where are you watching from? Also, yeah, if you want to say hello in the chat and maybe put where you're watching from as a bare minimum, that's kind of fun. But also, if you want to include more details, like what are you working on, why you're interested in fine-tuning LLMs or building AI pipelines, that's always really fun to hear as well. So a couple links in the chat. I'm going to go through some slides at the beginning, kind of set the stage, explain all the concepts, get everyone ready. But if you want to go ahead and poke through the code that we're going to run, I'm going to share that right away. I know sometimes when I'm at presentations, I want to go poke through the code or even start running stuff on my own. So as I go through slides, you can do that. And then I'm going to open up the code and actually go through everything. So if you do get stuck or anything like that, don't worry, we'll get to it as I run it. If you want to run all the code, which I hope a lot of you do, if you want to follow along, this is kind of a workshop style presentation. So hopefully, like, again, it's going to be slides, and then I'm going to open up code and we're going to run stuff and then actually fine tune a large language model. Also build a modern kind of efficient, reliable pipeline as we go. And then we'll also deploy our model and actually be able to interact with it within an app. So if you want to do that, there's a link to the code. And then we're going to use Union serverless today, and I'll explain more about what this is later. But there's a sign up link. It's free. There's no credit card required. It might take 3 to 5 minutes to get you onboarded there. And we're going to use that to basically build our pipeline and also use the GPU. You get $30 of free credit. So we're going to use that to basically use the GPU to fine tune our model and then also host our model afterwards in an application. So we're going to build, again, as people are coming in, I'm going to give it another minute or so before I start going to the slides. We're going to build this kind of production grade pipeline. We're going to download a data set, download a model, train a model, visualize the data, evaluate the model. We can predict batch sentiment. Sometimes I like to have this as an extra step in my pipeline as I'm fine tuning something. But that means I can pass in some data maybe that isn't in the actual data set that I learned from, and I can see kind of how it behaves on it. So I often have kind of some stuff like this in my pipeline when I'm fine tuning. And then you can embed visualizations in here too. So we're going to basically, again, go through the code, build all this. This is going to consume this data of positive and negative reviews. And then we're going to have our fine-tune model deployed where we could actually take some text then. Let me see if mine's still up. And then this is our fine-tune model running the backend. And we can see that it classified that as negative. Let me take another one that's probably positive here. And then we'll run this again. And hopefully it classifies it as positive. So we're going to go through the step, building this whole pipeline, train a model, and then deploy the model. And what we're going to learn can be scaled to more complex models. So again, we'll talk about the model types here in a second on the slides, but just now we'll go through, this is going to be kind of, an hour-ish workshop. So you can't learn everything or use the most robust models or data sets to fine tune in that amount of time. And we're also going to talk about some more efficient fine-tuning techniques called LoRA and QLoRA. You might have heard of those before, but we'll be talking about those as well. And then if you have questions outside of the workshop or just later about anything, you can join our Slack channel, slack.flight.org, and I'll talk again more about Flight, but Flight's our open source orchestration tool that basically Union's built on. So a lot of stuff that we're going to see today, you could also implement in the open source with Flight. So check out flight.org for more information there. And we just yesterday released a kind of version 2. And you can poke around with the SDK on GitHub. Always appreciate GitHub stars too if you're looking at it. Just released yesterday. So we have some really exciting new features that if you like what you're going to see today, you're going to really, really like version 2, which again, we just kind of previewed yesterday, and you're going to see more of that come out in the future. So with that, I'll go into slides. I think I see more people joining in. Also, links to everything are in the description. So if you are coming back to this and watching the recording or during the live workshop and you don't see the links in the chat, you can come back and look in the description. I'll share the sign up link and the code links just one more time in the chat. These are what you'll need to get running. And we're going to run in Google Colab. So if you open up that GitHub link, you can click this open in Colab button, and then you should be able to run all the code here. But again, I'll go through this when I get to it, after I go through the slides. So is everyone ready? I think I saw some people said hello. They said they're watching from San Jose. Someone's watching from Mannheim, Germany. Awesome. What time is it over there? And they also said they're working on LLM fine-tuning, RAG for a company, internal use cases. Very cool. I'm also would love to know kind of like what models you're using. It's always interesting to kind of hear about like what models people are using and what, like if they're working for you. Are they small model, big model? All right, so let's get going in the workshop. Again, for people just joining, this is going to be a workshop on fine-tuning an LLM. We'll use a BERT model, but again, this can extend to any other type of really model in the Hugging Face ecosystem. You can just change a couple lines of code. And then we're going to build a pipeline and also serve the model. So if you're new to fine-tuning, this should be fun. If you've never built a kind of production-grade pipeline, hopefully this will be interesting as well. If you've never done either, you're going to learn both of those today. And like I said, we'll also actually deploy the model so you have a model you can go interact with later. Just a tiny bit about me. My name is Sage Elliott. I work at Union.ai. Again, we'll kind of see this in action. Most people know us for our open source called Flight, F-L-Y-T-E, came out of Lyft originally. It's one of the more widely used open source orchestration tools for building complex pipelines for AI. Like I mentioned, we just came out with version 2 yesterday, or previewed version 2 yesterday, and it's really exciting. It's a little bit more dynamic and really, really fast. I live in Seattle, so if anyone else happens to be in Seattle, let me know. I run an AI book club. Every month we read a new AI book. We just finished yesterday and discussed the reinforcement learning for finance. The next book is building agentic systems. So if you're interested about that, you can follow me on LinkedIn and I post about it there. But if you're interested in going through the kind of AI agent book, let me know. And previously I've done a lot of work in computer vision, ML monitoring, evaluation, kind of the MLOps space in general. And then before that also in the hardware space a lot with some IoT companies and a little bit of robotics as well. So I love tinkering around with hardware stuff still. I think combining hardware and AI stuff is really, really fun. So again, if you like that type of stuff too, also feel free to message me later. And then about you. So I actually saw another chunk of people join in. So again, please say hello in the chat, where you're watching from, what are you working on, why are you interested in kind of fine-tuning LLMs here. And again, you can join the Slack community and connect there with a lot of other people and do a more permanent introduction there as well if you want. Oh, also, I just want to check too for the people who are active in the chat. Awesome. Thank you so much for, again, posting there. Also, is my audio okay? Usually I am in a different setup where I have a really good microphone, but I'm not in that space today. So I just want to make sure that you can hear me okay, even if the audio isn't as crisp. Hopefully you can still hear what I'm saying. So just a tiny bit. Okay, cool. Thank you so much. Sam said audio is good. Fine-tuning. So why do you need it? You probably kind of already aware of this, but most LLMs, like the big foundation models, are trained on a lot of general data, not your domain. They might not have your tone or specific kind of tasks that you're asking baked in. So if you're actually taking, most of them are kind of okay with this now, but originally they weren't all good at function calling or being able to call tools if you're building like agents. And so that was kind of a thing that you'd actually want to fine tune them for. A lot of now like foundation models kind of have that baked in a little bit, so you don't always have to worry about it. But if you're using smaller open source one, it's still something that you might want to do a lot, again, for agentic applications. But you also can just help the model on specific tasks like the specific analysis or support, or be a more of a domain expert or good at a task like summarization with new data. So again, you have a big foundation model trained on a whole bunch of stuff, but you're just building healthcare chatbot or something. It doesn't need all that extra knowledge all the time. And it might not be the tone or actually have the knowledge, even if you're using RAG or something like that, to answer appropriately. And then this is a big one where I actually see a lot of people want to bring in smaller models. Like, so if you can fine tune a small model, that can outperform those larger base models. They can be a lot faster and also a lot cheaper at inference. So you, instead of using a big base model API, you might have your own smaller model, and then you're able to host that pretty cheap. And we're actually going to use a small model today and talk a little bit more about kind of how cheap it is and why it's actually probably one of the most widely deployed models right now. You can also use it to help reinforce like your safe, compliant, and desired outputs for sensitive applications. And then, like I mentioned, agent tool calling and function calling. I think this is a big thing. We're going to see a lot of smaller models coming in and fine tune them for specific tasks in your kind of agent workflow or agent systems. And I know I think it was Alexander who mentioned they were fine tuning LLMs. I'd love to hear about what kind of if you can share what the problems about why you're fine tuning. That would be interesting to hear about. So a little bit about parameter efficient fine tuning, which we're going to implement today as well, is there's different versions as well, but these are kind of the top three that you're going to see a lot talked about a lot right now. So you have full fine tuning. That means we're going to load in a full model and then kind of train all the weights in there. Now, a lot of the models are really, really big. You've probably seen, it's like 3 billion, 400 billion parameters. Updating all those weights with new data takes a lot of compute and usually takes a lot of time. And so a lot of people don't have GPUs or hardware that they can easily do that on, or they don't want to take up all the time to do that. So there's different ways that you can make a more efficient fine-tuning process. And one of those ways is called LoRA, which stands for low rank adaptation. And this adds basically a trainable matrix in between layers. You can insert what layers they go in. Usually there's a few that are chosen. And this makes a smaller matrix, and then you just update the weights in that matrix, and then you can actually get pretty good results for your LLM behaving like it's fine-tuned. And a cool thing about this too is you can actually then swap out those matrices for different fine-tuned matrices. So you can have like a base model, train a matrix for either like image generation or, again, different conversational AI things, and then you can actually swap out the matrix pretty easily when it's deployed, which is kind of cool. They have QLoRA, which stands for quantized LoRA, quantized low rank adaptation. And this combines the LoRA technique we kind of already talked about, but then you can also quantize the model. Basically, you're smushing it down, make it smaller, more efficient to deploy. In this case, you're actually doing that to load it into memory. So if you have a smaller GPU, you can quantize the model and then just load in these, or just train these smaller matrices. And you can actually then load in like your LM into a much smaller GPU without as much memory. So if you don't have like a whole bunch of A100 sitting around or other big GPUs, you can do this in more available hardware. And then you can train those matrices. And then you can take those matrices when they're trained and then just put them into the full model that's not quantized and still get pretty good results. You get kind of deteriorating results with all these sometimes, but they work pretty decently well. And if you don't have the hardware for it, they can be really good options. And then so we're going to use libraries today, PEFT and bitandbytes. They're both libraries that I think both of them are run by Hugging Face. I know PEFT is for sure. Hugging Face makes a lot of really good tools. We'll also use their transformer library. And then also, we won't use this today, but if you're just interested in more quantized things or in more efficient ways to fine tune, you should check out the stuff that Unsloth is doing. They also publish quantized models all the time to Hugging Face Hub. So you can actually, you don't have to go through the quantization steps yourself. You can pull in their more efficient models often. So they're a really cool company. Again, if you're interested in the space, go take a look at what they're doing, but we won't use them today. And this kind of a graph shows like this would be an input and output of one of the weights inside your LM. And then this is kind of down sampling it from the inputs and then to the to a size of 8. So you're having these really large matrix, and then it basically becomes a smaller one, and then it becomes large again as the output to the other weights in your neural network. And the BERT model. So we're going today fine tune a BERT model. Has anyone heard of a BERT model before? Usually a hit or miss. Like some people are like, oh yeah, I've heard of it. Some people haven't. Totally fine either way. It stands for bidirectional encoder representations from transformers. And it was actually kind of, at least in my opinion, I feel like one of the first large language models that started getting a lot of recognition and being used in a lot of places. And it's still actually used all the time. It might not be in the news as much anymore. Like there's these bigger models that are more interesting, like DeepSeek and stuff like that can do way more. But BERT models are pretty small relative to that. So the one we're going to use today is called DistilBERT. and it's only 110 million parameters. So we can actually usually load that into a lot of GPUs pretty easily. And you can fine tune it to be really good at something like text classification, semantic search, named entity recognition. And so these models are actually some of the most deployed models, at least as of a couple months ago. I think in this blog, they talk about it. There's a new version called Modern BERT that seems pretty interesting as well. And often when I talk to people actually putting AI in production, this is one of the more commonly fine-tuned models that they put out in production. And because it's so efficient, and then you can train one or a whole bunch to be really good at recognizing certain things. So if you're, for example, doing a task like looking at every text that comes through some sort of messaging forum, you want to make sure that it's not toxic or racist or something like that, you can have a fine-tuned BERT model that can be really, really good at classifying that. And then you're not doing an API call to like a big foundation model every time. That would be pretty expensive. And then you can also have a whole bunch of different models that you can stack. So like you could say, does this text meet certain criteria? If so, then have another efficient model go look at it. So you can stack these fine-tuned efficient BERT models. And here's the, oops, sorry, my mouse is a little weird in my setup today. I have another monitor. It's not right in the place that it normally is. And I'll share the link to the BERT paper. And someone said, yeah, currently using Roberta for reinforcement learning, human in the loop for their personal project, which I believe is an upgraded BERT. Awesome. Yeah, there's different variations of BERT that you're going to see around. And like I mentioned, there's even just one came out not long ago called Modern BERT that's even a little bit more efficient too. Catch you up on the chat here real quick. Alexander said they're aiming to speak our language based on our SharePoint to match the tone of our documentation. Yeah, okay, yeah, so that makes a lot of sense. We talked about fine tuning and matching tone of their language and stuff like that, and that's exactly one of the use cases. So very cool, awesome, thank you for sharing that. To kind of make an efficient fine tuning pipeline, or if you're going to be fine tuning and not just as like a little personal project, and you're doing this as a team, a lot of times you want to build out kind of a whole pipeline for this. Even if you're a personal project, you're going to have some form of pipeline. It gets a little more tricky when you want to do this at scale and with the team and stuff like that. And that's the stuff we're going to talk a little bit more about today as we implement it. But at the bare minimum, you're always going to have something like this for your fine tuning pipeline. Again, you usually have more steps as well. And you're going to use MLOps, which is the set of practices of combining tools and best practices together. And then I kind of use these words, but you can use different words. To kind of deploy and maintain your machine learning models in production reliably and efficiently. And in the experimentation phase too. Basically, you're probably going to be running this loop a whole bunch of different times. So you're at least collecting your data from somewhere. Again, you're usually probably doing like pre-processing on it as well. Then you're going to train your model. Then you'll evaluate the model, make sure that it's kind of behaving the way you think it should. And then you're going to ship that model. And the shipping the model looks really different for different use cases. Like this could actually be on an edge device, like in a farm somewhere. It could be in the cloud, like we'll do later today. Once you ship that model, then you want to be able to monitor in some way to make sure that it's behaving the way you think it should, and it's not, doing a lot of hallucinations or bad predictions. So there's different metrics you can look at depending on what your kind of application is doing. And then you're going to basically run this loop over and over again, because if you're monitoring in production, you're probably collecting data from production that you can then fine tune your model over again and make it perform better. But even from all these phases, you might go back to the previous phase. Like you collect data, you train a model, you evaluate the model, you go, oh, that's not enough data. We need to collect more data. Then I'm going to go back to this loop. Or, oh, like I need to adjust hyperparameters. Then we're going to go back to the training loop. So basically you're running this pipeline from different steps over again, a whole bunch of different times. And then again, improving your model, hopefully every single time, or learning about what doesn't improve your model. That can happen too. Again, there's different steps like vector databases, processing your data, A/B testing, et cetera, that you'd probably add into this. So this is kind of a simplified pipeline. But has anyone built a pipeline like this before? I know at least one person has. They're doing some fine tuning. You probably have kind of all these steps together. Fortunately, there are so many libraries that make a lot of these steps easier. So you have things like PyTorch, weights and biases for monitoring, Hugging Face transformer is what we're going to use today. but you kind of want to tie all these together in a way to make it, again, reliable and efficient. And those are the words that always come to mind for me when I'm like helping people implement workflows or pipelines. Because again, if you're doing this at scale with a lot of data or sharing with people, or you're doing this many, many times, these are the things you kind of want to think about when you're implementing this. So building reliable and efficient workflows for your AI application, you want to think about scalability. How do you facilitate the scaling of your workflows to handle really large data sets and complex models? Like sometimes we work with customers in healthcare. They have really, really big image data sets, or self-driving cars. Images are usually really big. They also have like point clouds and self-driving cars, not just images, so like a different kind of image. So we want to be able to scale up like massive compute to load in all this data, load in very large models, and then efficiently scale it down when you need to as well. You want to have reproducibility. So you want to ensure that when you do run your workflow, the data and models can be consistently reproduced. And this makes it easier to collaborate with people. You all share the same environment. So with just those two things, like if you're familiar with Kubernetes, that might kind of sound similar. And what we're going to use today, Flight and or Union, again, Flight is the open source, is actually built on top of Kubernetes. So we make it really easy to scale up the infrastructure and load in images that contain the exact environment you need. And we'll actually see you don't have to do it with writing Docker files. We'll do it all in Python. There's a thing in Flight called image spec, where you can define your environments in Python, and then it'll build the image for you. So we'll see this in action later. You also want to have versioning, not just your code, which you're probably already doing, but also tracking the data and model versions and all the hyperparameters and stuff going in. So especially, I mean, this is useful for any team, especially when it comes to debugging like your model. Like I've done this a lot before, where I didn't have an exact version of the data set or something in the past, and I had a model version, and I was trying to understand why it learned something the way it did. And then you want to tie it back to the data set usually, and the code, to see if there's any hyperparameters in there. So this is really, really useful for debugging. You can also think this is useful for if you're doing this for agents as well. Going back and seeing every time it was run, all the different steps in the pipeline, the states that they were at. This is also sometimes required for some fields like healthcare and finance. Sometimes you actually need kind of that lineage to get certain models approved. Developer efficiency is a big one, where you want to allow your AI engineers or ML engineers to focus on actually the development piece, not just like if you don't give them easy access to infrastructure, it can take a lot of times to get experimentation or deployments done. So it's pretty common when I help people implement like a modern MLOps pipeline. They go from doing like experimentation from like weeks to days. And then cost efficiency is obviously important. A lot of people think about this, higher ups or like the bottom line for your company. This is obviously usually really important. We want to optimize your resource usage, like retries, add caching into your pipeline. So every time you run that workflow, it's not using as many resources. And this can also reduce your developer efficiency if you're using caching. But often, like again, when people like just built out their original pipeline and then they go in and create a modern one, we'll hear sometimes like they'll have like over 50% cost reduction, which kind of blows my mind sometimes. And again, we'll get to the code here shortly, but just taking a closer look at some of the efficiency gains. And you can think about how to implement this in anything. So again, today we're going to use Flight and Union. Hopefully these concepts are interesting, even if you use different tools for it and implement them one by one, like by yourself. So you want to think about optimizing for local and cloud development. Is interesting. It might seem really obvious, but not every tool or team is set up to actually do like local pipeline development first and then kick off for production runs. So can you run basically your pipeline, maybe even as a smaller model, maybe has a smaller data set as you're developing it? This really makes the iteration piece of development really, really fast. And then when you feel pretty confident that your pipeline is going to run with the hyperparameters you want, you can kick off a more production grade run in the cloud with all the extensive GPUs. So really, there's a lot of time saving. Otherwise, you might have to kick off a production grade run. You have to wait for a container to spin up, wait for it to run, then get an error code in some platform somewhere, and then go make a change to it. So big developer time saving here. Leverage caching in the pipeline. I mentioned this before, but just to kind of hammer the point is you can cache tasks that if you're going to rerun that workflow over and over again, kind of like we looked at before, like let's say we're downloading the data set, pre-processing the data, but we're doing hyperparameter tuning here. I can rerun this whole workflow really easily, still have the entire lineage tied to it, but then just change hyperparameters in one task and then have these other ones cached, so I don't have to rerun those over and over again. And another thing that is not exactly caching per se, but kind of, is retries and fault tolerance. So if you are also running your pipeline and you're doing some sort of API call somewhere, or just running this at scale, something's going to fail at some point. You can actually add retry, so you have this cache state. And then if this failed here, you could say, well, retry it like 3 times before failing the whole pipeline. And you can take this cache state and then just run. So you can actually gracefully recover most of the time from like something that goes wrong in your pipeline, just because something doesn't run right. And then you can rerun it from these cache states. And that saves a lot of time. So you don't have to rerun this whole thing every single time. And because everyone's talking about agents, and we are at an LM workshop, this is also really interesting for agents. Imagine if you have an agent, and if I don't know if anyone's done this yet, but I've been interacting or building and playing around with agents and adding things like chain of thought prompting into your agent. So it actually does a lot of thinking, like if you use DeepSeek, or even a lot of the OpenAI models do this now, where it thinks a lot and then does some sort of action based on it. That's a lot of tokens that it uses. So if you did like multiple steps and you're using a lot of tokens and then it fails because it did an API call and the tool is down or something like that, you can also do retries in the same way, where you could have this cache state after all the chain of thought thinking on your agent and then retry a task again. So there's a lot of stuff like this that's really interesting that can save a ton of money again over time, especially if you're doing it at scale. So if you have a lot of people using your agent over and over again, that can add a lot in money, but also just efficiency. So it doesn't have to rerun that whole process again before it gets the output. Task level resource management and containerization. This is also, again, might seem obvious, but not everyone is set up to run task level resource management. So basically, again, going back to your pipeline here, we have like downloading data set. Here you can just be using your CPUs, but when you're training the model, you probably want to use GPUs. So here you can set every time you run a task exactly what containers in there, but also the compute that is needed. So for training a model, we need GPUs. For just downloading the data set, we don't. And if you had just one compute resource assigned to all these tasks, then you'd kind of be wasting a lot of GPU time that either you're paying for or hogging from other developers that could be using it. And the cool thing too is about once you set this, you should be also be able to kind of monitor in production how much tasks are actually using. And then if you over provisioned it, you can kind of pull it down. And then again, if you're running this at scale, that can also really add up quite a bit. And then the last thing is just having some sort of type safety. If you used other languages, you're probably already familiar with typing, but Python doesn't have it built in natively. So you can think about adding in type safety, and there's a library that does this. I'm blanking on the name. I mean, Pydantic does a little bit of this, but I think there's another one too that you can take a look at, where you can add in the type hints in Python. And then this just, again, helps with kind of debugging time, and also readability for sharing code across teams. So these are kind of some things that you can think about that can have a huge gain in your pipeline, especially when you're working with a team or things at scale. There's so many opportunities that like maybe sound a little bit small, but again, when you're doing this at scale with a lot of people, they really, really add up for a lot of efficiency, both in developer time, but also costs. And so when you implement these in your company, people usually love it. And it's also not uncommon that people get like promotions. I can't guarantee, obviously, it's going to happen. I don't know what your company's like, but it's kind of a joke, but also not really, where it's like people come in and implement these pipelines and then they're like end up running the team or just running that pipeline, just running kind of the MLOps practices. So if you're interested in MLOps, it's interesting to think about kind of all these opportunities where you can gain all these efficiencies. So today we're going to use Union serverless to actually run the code, again, built on open source. So you can go check out our open source. It just takes a little bit more to set up. And I assume people don't want to set up a Kubernetes cluster live during the workshop. So I'm going to share the link again in the chat so you can go to the Flight repo. And Flight's used by thousands of companies in production today, again, for the orchestration. And this is a code snippet. We're going to go jump into the code here just in a minute. But basically, we write Python code like we normally would. And then we're going to add a decorator to this. And then you're going to add in parameters like the amount of compute that you want, the container image you want that to run in. Do you want caching? All those different kind of things that we talked about that can really help your pipeline. You can run in cloud, on-prem, do declarative infrastructure, just like we saw. It also has versioning built in, so every time you run a workflow from it, you get a kind of snapshot of the data, the code, etc. Caching, we see what that looks like. We're just enabling it there. Type safety, it's a flexible plugin ecosystem, but also you're just running Python code most of the time, so most things can kind of work out of the box with it. So let's take a look at this as we actually go and code. So enough slides. Does everyone feel kind of, I know it was fast-paced, hard to kind of cover everything depending on your background, but does everyone kind of feel a little confident in the subject matter? Let me share this link again in the chat. Go to the GitHub. You can always start that, come back later. And then there's still time to sign up. Again, there's no card required, and you get $30 of free cloud credit. We're only going to use like a very, very small fraction of that today to train our model. And once you go, open up that GitHub link, you can click this Open in Colab button. And then you don't have to do this, but I like to go to File and then save a copy in Drive. And this is going to create my own very copy of this. So I can actually edit code and change text here and come back to it, and it would be in a saved state. And then once you're here, this can take a minute or two to download everything. Just run this first code cell. So scroll down a tiny bit. You see this code cell here. You can click this play button, or when a code cell is highlighted, you can hit Shift Enter, which is what I do a lot during the workshop. So if you don't see me clicking it, that's what I'm doing. And this might take a couple of minutes just to install the dependencies here. Part of the reason why it actually takes so long is Google Colab is kind of Google's way of hosting a Jupyter notebook, but they also give you a whole environment here with pre-installed stuff. And we're installing different versions of some of the stuff, so I actually have to uninstall like the version of PyTorch and stuff. So it takes a minute here. That's the reason why. So if you get running this, it'll take a couple minutes, and then hopefully you'll be good to go if you signed up as well. I'm going to take a break from talking here and ask in chat again, like, were you able to open the notebook? Are you running this code cell? Is everyone ready to run some code here? Were the concepts interesting or relevant to you so far? Alexander says code cell is running. Thank you for always being so responsive, Alexander. It makes it way easier for me to know that things are working. And again, while this is installing, if you haven't already, I'll share the link one more time in the chat here, is you can just go ahead and do the sign up, because next we're going to authenticate. So if you don't have an account here, you won't be able to authenticate. And then also we'll go through, like, you can take this code and modify it later as well. All right, so mine is done installing. Again, yours might not be quite done yet. What you want to do next is run this next code cell in this authenticate section. So this actually is in code cell here. This is if you're like a commercial user. Scroll down here with this little finger point. I think I put this on most of the code cells that you have to run. You can run this code cell. It's going to create a login once you've created an account on Union. It made a config YAML, and then it will generate this URL. You just want to click on this URL and then just hit next here. This has a little code. And then wait a second, and then I should now be authenticated. And so what this did is just made a connection to the cloud that we're going to train our model on. And it's going to give us all those workflow features that we talked about as well. And like I showed at the beginning, this is the workflow that we're going to build here. So I'm going to scroll down again, and what I'm going to do is run this code cell. This is what you should do too. Go ahead and hit run on this code cell, and this is going to start our training pipeline, but it takes a few minutes. So we're going to run the code cell, and then I'm going to walk through all the code that basically this is using, if that makes sense. So we're going to say union run remote. So we want to run this locally, which we're not set up with a GPU here in Colab at this moment, so it might not work. But if you wanted to run this locally, like we talked about, you can do local and then remote development, is you would just remove this remote flag here, and then it can run locally, and then you can just add in that remote flag, and then you can do like the production grade runs with the GPUs that you want. And then you can see that we're passing a path of workflows train pipeline.py, train pipeline, and then passing in some parameters here. Well, we'll talk about how this is working here in a second. Since it's your first time running, it'll also be looking for a container image and say it's not found and it has to build it. Mine, I've already run this, so it's already stored somewhere and it skipped building, and then it was able to actually just go ahead and kick off this run. And we can actually see that downloaded dataset and download model were actually already cached. So because I triggered the whole workflow and I ran this before with caching enabled on those 2 steps, it's skipping those, basically reading in the cache version of that state, and then it's already training my model here. So let's go through, look at the code. And then just before we also look at the code, I'm going to mention in this code cell up here, let me get rid of this output. This code cell here, we downloaded a GitHub repo. So all these actually exist as .py files in this BERT LLM classification pipeline folder. You don't have to open this up, so you don't need to follow along this part if you don't want to. Just showing you where these actually live. So we said we're targeting this workflows folder, and then we have this train pipeline.py folder, and then inside there's code. But what I did to make this easier for the workshop is I actually just put the code in the code cells here as well. And there's a write file function that's built into Jupyter Notebooks where it can overwrite an existing Py file or write it if it didn't exist already. But so these files are already existed. That's how we were able to run this before. And then now I'm just showing you what was in those files. So this makes it a little bit easier to run through the workshop this way. So let's talk about libraries as we import them. Here we're actually importing functions or tasks from some of the other folders. And again, we'll see these here very quickly next. The thing for this is we created what's called a workflow. If we go back to this workflow that we built here, each one of these are a task. So you have something like download dataset, train a model, evaluate model. Every one of those is a task. And the workflow is kind of how these tasks and data flow together. So the workflow that we built here imports tasks that we created that are in other files. And again, we'll see those next. And then we have this workflow decorator. We write a Python function like we normally would. We have some default parameters that we're passing in. And then we're basically running that download model task that we'll see the code for here in a minute, getting some data sets returned out of that, running the download model, visualize data, train the model, evaluate model, and then predict batch sentiment. So basically, we just built our pipeline here in that workflow. Or we built the workflow there, the flow of data, and then again, we'll look at these tasks. So this is also how we built the container image. So like I mentioned, is anyone familiar with Docker? And Alexander said, build in progress. Yay, awesome. So you should be good. If you got that far, everything hopefully is going to work very smoothly here from now on. If you've ever used Docker before, you might be familiar with writing like YAML Docker files. Inside, we can actually ignore this for now, but inside of Flight, there's something called image spec where you can give it a name. In this case, we're passing to requirements.txt, but you could also just put package names directly in your Python code here. You can give it a URL where to install from. This is just looking for a specific Python packages that can run on CUDA 11.8, but it could be, you don't need this, or it could be different CUDA versions. And then we have builder union. And so this is going to basically look and see, does this package or does this environment exist? Yes, no. And then if it doesn't, it's going to pull or build the image and then pull it down into our container. If it does, then it'll just pull it into the containers that we have. And every task by default is a container that's going to spin up and then spin down. And so we can also put packages that aren't Python packages in here as well. So this is kind of a really cool way of just you can be all in your Python project and build containers really easily for your tasks. And then this is what our requirements.txt looks like, just specific versions of PyTorch, etc. So scroll down. This is our first task file. We're going to look at data.py, which contains this downloading data set, and then also visualizing data. A cool thing about Flight is you can embed visualizations directly into your workflow. You have these different views too. So by default, you have Node. I kind of like this graph one for showing it. So you can click in here and then click on this deck button. And then you can embed any HTML or Markdown in here. And that includes things like if you've used Plotly and having interactive graphs, you can actually put them in here as well. So I always like to have a kind of data summary of my training data, whether that's computer vision, and I want to validate that I read in the annotations and images correctly, they didn't get all smushed, or the annotations were read in weird. And then with LLMs, like we're using text data today, and we're just doing classification on text. But we have like a positive review example, a negative review example, and then also the distribution, which is even today. But this could be really helpful to see like distribution. If there's way more positive reviews, our LLM might be better at detecting positive versus negative. And then I do this for all the training data, the validation data, and the test data. So when I go look at the model that we end up training, I can actually come back to this workflow and see where that model was generated, see the entire lineage of like all the hyperparameters, but also have some sort of summary of the data set that's actually there for me to look at, which is really, really, really useful for debugging your models and understanding what's going on. So let's go look at building that task. This is just going to be the download data. First, we're going to declare artifacts. This allows us to basically have in this artifacts tab in Union, we can have data sets here, and then we can easily reference these and pull them down into other tasks or workflow. So we're going to also save a model as an artifact and then be able to pull this into an app later. But here, again, going back to that lineage piece, like I can see where this artifact came from, and then I can click here and go see everything that happened in this workflow. So really, really useful. So we're just going to initialize some artifacts here, and then we're going to create our download dataset task. So again, this is the Python function, the type hinting that we do enforce here. And then we add this at task decorator, and then we're just going to pass in parameters here. So we're saying container image is equal to 1, or sorry, container image is equal to container image. That is the one that we just looked at in the previous code cell. And then we're going to enable caching. So every time we rerun the whole workflow, this is not going to run by default. And we can just pull in that save state and save some time and our resources, so we are not downloading data every time. And then we request specific resources. Here we want two CPUs, 2 gigabytes of memory, and we'll up this for our training task where we'll actually add in a GPU. But this is really, really neat. So task level resource management, again, all just in your Python code here. Really, really easy to manage your infrastructure without having to go through a lot of configs or an ops person or something like that. And then we have our Python function, just like I mentioned, kind of right like you normally would. It's going to return these annotated data types that's going to create the artifact. We're just going to import pandas, import scikit-learn, and here we're going to load in from Hugging Face a data set called IMDb, so it's positive and negative IMDb reviews. Then we're going to split the train data set, so we'll also get a test data set. So we're going to have train test and validation. We're going to use the the train test split thing from scikit-learn, and we're going to set the test size to 20%. So we're going to save the extra 20% to be another data set, and we'll stratify on the label. Stratify just means we're going to try and get even amount of each label that was in there, and then so it's not fully skewed towards a negative or something like that. So it kind of mixes them up, pulls in the even amount of positive and negative in this case. And then we're just going to save all of these files to CSV files, and then those are going to be returned as artifacts. And then we have this visualized data. This looks like a lot of code here, but basically we are just reading in those 3 data sets that we just saved. Sorry, that preview gets kind of annoying there. And then we're going to get the first one from positive and negative, and then put them in that report that we saw. And then we have the little plot distribution that's going to give us the distribution of negative and positive reviews. And then the interesting thing is we can actually write a little HTML report here in Python and then add variables like our images or the reviews. And then we'll initialize a deck, and then we're going to hit append in our HTML report, and that then inserts the deck into, let me go back just to show you. Then inserts the deck into here, and then if we say index is 0, then I'll put it at this first section. And inside our deck by default, there's some other things like you can look at all the source code. Also, all the code gets versioned here. Again, this makes it really easy to kind of go look at everything, including code for your whole lineage in your pipeline. What did this work so far? We're going to go into the model.py. This is a little bit the more interesting one. We'll look at implementing LoRA and the full fine tuning. So we're going to initialize one more artifact. This is going to be our fine-tuned model. And then we're going to create we're going to download a model and then we're fine-tune it. So this is going to download our model here, similar like before. We're going to enable caching. So if we rerun the whole workflow, this won't run. We only need CPUs and a little bit of memory again to download this, and this is going to return it as a flight directory. So there's two special types in Flight called flight directory and flight file, where if you return those by default, what it's going to do is serialize and deserialize the data that goes between tasks. But also, like I mentioned, if you're not used to working with containers, it's kind of interesting because you're going to download this model. It's going to spin up a container. So it's going to spin up like a compute instance for that. Download the model, and then when it spins down, where does that go? So you have to basically write data to some sort of blob store, and returning it just as a flight file is already going to do that. It's going to write it to a data plane, or write it to a data storage that you either set up in Flight or with Union. And then we're going to be able to access that data that was in another container into another container. So it makes it really easy working with containers. Like there's some stuff that just feels really natural, like when you return as a flight directory, now you have access to that data in other tasks. So we make it pretty easy. So we're going to download the model. And in this case, we are downloading this or using this auto model for sequence classification. So if you want to download a different model that isn't a BERT model, you just change this out to, I think it's auto causal model. And then you have the stop from pre-train, and you pass in the model name. And that's a parameter that was in our workflow, or that we can actually pass in when we run this workflow. In this case, it's going to be DistilBERT. We're also going to get the tokenizer for that model. The tokenizer is the way that the data, or in this case, text, is chunked up. It's chunked up in kind of specific ways, like how they break up words. Most models have a tokenizer that they were trained on. So you usually want to use the same tokenizer that comes with that model, because it'll break up the text the same way when you feed it into the model. So we're going to save both of those and return those as a directory. The directory is how how Hugging Face models are saved. They're not just like one PyTorch file. They actually get a whole directory. So we're just going to save that directory. Then we're going to read in that directory when we fine tune it, which we're going to do in this next section here. We have this train model function. We have some parameters that we're going to take in. They're going to be the model directory that we just downloaded, the train validation sets that we also downloaded, the number of epochs. Basically, this means the amount of times we're going to fully look at our whole data set. And then we have a string here. We're going to pass in tuning methods. So by default, it's going to be full fine tune, but you could change this to LoRA or QLoRA, because we're actually going to implement in both LoRA and QLoRA like we talked about. And then have it as a parameter that you can pass in, and then I'll choose which one to use here. And then we have LoRA R, which stands for rank, and then alpha and the dropout. Basically, the rank is how much it's going to squeeze down the matrix. So when we saw the slide, it went from like 4,000 something to 8. You can adjust this number as a hyperparameter that you might need to adjust depending on your LLM and types of data. The smaller this is, the smaller the matrix is, but you also lose a little bit of the fidelity there. And then the alpha is, I think, the kind of like an importance value that you can give to the matrix as well. And then we're going to load in our data sets. So we just load in those training and validation data sets. One thing important for this workshop is that we're just looking at the first 500 samples here, and then the first 100 samples for the training and validation data set. You could get rid of this whole part together, this .sample, and I'll read in all of them. I think there's something like 25,000, so it just takes a lot longer to train, but you will get better results. But just for this workshop, we don't want to spend like an hour or more just for the training phase. And then we're going to read in those data sets and put them into this kind of Hugging Face format with this data set feature here. We're going to load in the tokenizer that we had downloaded before. And then we'll create a little function that's just going to read in the text and return it tokenized so that our LM can read it in kind of the way it knows how to. And then we have our load model setup. And so this is where we actually either implement LoRA QLoRA. And again, Hugging Face has these libraries that make it really easy, which is really cool. So from transformers, we're going to import bits and bytes config. This is the configuration for how we want to quantize our model. So we can say load into 4 bits. There's like 8-bit as well. Basically, this is, again, squishing down our model to be more condensed so we can load it into a GPU more efficiently. And then there's different types you can give it. I'm blanking out with this is a float but I forget what the N is stands for. But it's a more efficient float number. But I'm blanking on the N, what it stands for. We can look at that later if we want. And then some other parameters. Basically, these are the inside our neural network. The ones that we don't want, or the ones that we don't want to quantize, are the classifier layer and pre-classifier. Basically, because we're quantizing our model just for the training, but we want the classification layer to stay the same so that the quantization doesn't mess up the actual training piece here. And then we have our model we're initializing, again, from auto model for sequence classification. Pass in our model name, pass in the bits and bytes config, and then you should be good to go. And then here, if it doesn't contain LoRA, we're not going to do the LoRA config. We're just going to load in the model like we would before, auto model for classification without any of the config stuff. And then here, if it contains LoRA QLoRA, we're going to go ahead and add the LoRA config, which is again just from the PEFT library this time. And we're going to add LoRA config for sequence classification. In this case, we're just going to pass in the LoRA rank, like I had mentioned before. So smaller, fewer trainable parameters, larger is more expressive, but again, not as efficient. So this can be a balance that you can find. And then the alpha is the scaling factor applied to the output to control the impact of the adapter. So I think the rule of thumb is that you kind of start just with doing 2 times the rank, but you can adjust this. And then these are the layers that you want to apply the matrices to. These by default are the query, key, and value layer. These are usually the 3 spots where you want to add the fine-tuning matrices to. And this exact value that you pass here might change even if you import a different BERT model, just because even if you're doing query key value, it just might have a different name in the layer. So just keep that in mind. If you're using different models, you might adjust the actual string that you put here. And then we're going to load in our model with those configs or no configs. And then we're just going to add some training arguments, like the batch size, how much data will you want to read in at the time to learn from. And then we're just going to call trainer with all those arguments, and it's going to start training on the data that we passed in. There's other stuff that we can add in here, like early stopping is something you often add into deep learning, where you can evaluate how the model's doing every epoch or every set amount of epochs. And then if it's just not improving or getting worse over a certain amount of time, you can go back to the previous state that it had the best results on and then do something called early stopping. So you used to say, like, well, look at the data 100 times, but if it doesn't keep improving after 5 times, then it's not going to run that 100 times. And then we have our evaluate model function. We're going to load in our train model after the fine tuning, kind of load in like we did before, same with the tokenizer. And then we're going to read in the holdout kind of test data set here. Again, just 100 samples. If you want to read in the whole thing, you get rid of that. Then we create a little NLP pipeline here. Pipeline is just something built into Transformer where you can pass in the task type, the model, the tokenizer, if you want anything like truncation or padding, and then it'll get a prediction from it. So here we'll get the prediction, and this actually gives us, I don't think we opened this up yet. So if I open up the evaluate model, we have another deck, just like the data evaluation task. Because we're doing just classification, we can actually use classification metrics here. So if you've seen a confusion matrix before, it's a cool way of seeing how well your model kind of did on a specific class. So for class 0, it got most of them right, and for class 1, it also got most of them right. We can see that it did 7 mispredictions as class 1 and 5 mispredictions as class 0, even though they belong to the other class. Confusion matrix are really cool when you have more than binary predictions, so you can actually see, like, if one specific class out of, like, let's say 50 or something like that, it was doing really bad job in mispredicting some other class as that. And then we have accuracy metrics, like it was 88% accurate, F1 score, precision, recall, etc. And if we go back, you can see that basically we're just take that model, run it from that test data set, see how much it got right, and then give us the accuracy score, give us that heat map in Seaborn, create another little HTML report, and then embed that in there. And so again, I know we're going fast, but I just want to make sure that we can go through this content. I'm happy to answer questions. Let's actually run this next code cell. And again, this will take a few minutes for you to run because that's to build an image. So go ahead and run this, and then I'll talk about serving our model. And just to recap kind of what we did here is you were able to run code, hopefully. It sounds like Alexander was running. They had build in progress. Hopefully everything ran smooth. Let me know if your model finished training. And if anyone else in the chat also wants to let me know, that'd be great. But basically, we built this pipeline, downloaded our data set, downloaded a model, trained the model. Again, we have things like we can look at deck here, get these cool metrics. And then actually, I had mentioned I did this kind of batch prediction where I can throw in some other inputs. So I just said, just as a quick test here, this is a good movie, this is a bad movie. Those are the texts that I put in. And the outputs were label 1 and label 0. That was labeled good and bad. And I can actually see it's pretty high confidence score on those texts. And then from there, we also generated a few artifacts. One of them is this fine-tuned model that we can then pull in and use in an application. And again, I can go in and see like exactly everything that led up to this fine-tuned model, which is super neat for debugging, like I mentioned. And in some cases, you need full lineage like that in some industries. So now let's go ahead and serve our model. We're actually also going to use this in Union as well. We have in this apps tab, I have some apps here, and I have mine is running, I think. This is going to give us this Streamlit application with our model in it. I'm going to walk through all the code here in a second, but I'll just show you what it does. So we trained our model. Now we have this UI that can interact with it, and I'll say, I loved the movie. I'm sure this is going to predict good. And we get a sentiment prediction back. Let's go find a more complex review. We'll take a 1-star one first, just to make sure. So let's put this in. Again, I'll go through the code, but yours is probably still spinning up here anyway. So predicted that was negative, and let's go take this 5-star one. And that predicted positive. Awesome. So it's working. Let's take a little bit of a harder one. 2 stars. That leans more negative, I guess, right? But it's going to be short too. Our model is trained on longer reviews. So, all right, predicted as negative. Worked pretty good there. So we go back to the code. Let me go through what's going on here for the deployment piece. So we have inside Union something called apps, and you can deploy whole applications like we saw with Gradio or Streamlit or any UI that you want there. Gradio and Streamlit just make it really easy. They're Python libraries. They make it really easy for building UIs like around models and stuff like that. You can also host APIs, so it doesn't have to be a full app here. You can actually host like an API endpoint for your model and then call that from any other service that you want. So again, these exist already as files. We have this app.py, and we're going to initialize our fine-tuned model. And someone said, oh, could you give a link to the code? Oh yeah, so links should be in the description, and up in the chat, here's a new Colab link. And someone said their mistake. I was too quick and didn't wait for the build to finish. Now the oh yeah. Sorry, I should have mentioned that too. So this cell, if you run this too early and your artifact isn't generated from the training pipeline, it'll fail because it's looking for an artifact to exist there. Great call out. I usually try to call that out, but totally forgot. Thank you. All right, so we have this app.py, and app.py is us basically defining our app, like how it's going to run and scale. So again, this is all in Python. It makes it really easy to have like all these cloud scaling metrics that we'll see here in a second. But basically, we define our artifact. This is what we're going to call down. This is the model that we already fine-tuned. We have image spec, kind of like we saw before. We just have our Python libraries directly typed in here though. So again, you don't have to write a separate Docker file or anything like that. You can just do this in your Python project. Then we're initializing our app. We're going to call the Streamlit app, use app from Union that we imported above, give it a name. The input here is going to be the fine-tuned model. The cool thing with artifacts is that once you have them defined, you can just call this .query on it. It'll automatically bring in the latest version of that model. But you can also pass a specific hash. So if we go look at artifacts, we can actually see like all hashed here. Every time we ran that workflow and it generated a version of that model, again, that's a separate version as well that came from that version of the workflow. So I didn't show this here too. You see workflow version is listed here. If we relaunch this workflow, it gets its own version as well. So everything is versioned all the time. Makes it really, really easy to roll back if something went wrong and debug, like I had mentioned. So you could pass in a specific hash version, get a specific type, otherwise it'll pull in the latest one. Then we're going to define our container that our app is going to run in. So that's what we did above in image spec. We point at that variable. Then just like we did in our tasks, we can define limits and resources for our app to run in. So here we're giving it 2 CPUs, 24 gigabytes of memory, 1 GPU, and 20 gigabytes of ephemeral storage. And then the GPU type, we can actually specify. I forgot to mention this in the training task. We can actually import specific types. So like in L4 is what we're going to use here, which is a lighter weight GPU, but totally works fine for Distilbert. But you could also import something like an A100 and use a more intense, robust GPU when you're using like a billion parameter model. Then we want to have a port that our app is going to serve on, and then we give it another file that we'll look at next. This is kind of actually contains our Streamlit code. This is just kind of how our app is set up in this code. And then we have arguments to launch it. And then this is really cool too. You can set the minimum and max replicas directly here. So min replicas means when someone isn't using your app for, in this case, we have it set to 5 minutes, then it's going to scale down. And so it's going to scale down to 0 by default, and you're not paying for any compute. And then when someone starts using it, it'll have to take some time to spin up, and then it's going to go to 1 replica. But you could set this to like replica 1, and you'll always be having one container run your app, so it'll be really fast if someone visits it. But then you're paying for that compute as it's up. And then we can set scale down metrics and scaling up metrics. So this is saying if more than 2 people visit my site, spin up another replica if I've allowed it. And then by default, this is commented out. But if you actually want to make the app today that we're going to show public, you could just uncomment and then run this code cell and then run the command above. And then I'll make it a public URL. Otherwise, you'll have to be authenticated into your Union account to see the app that we're going to publish. And then this is our Streamlit app. It's pretty simple here. We're just loading in the BERT model from the get input that we defined in the above code cell, and loading in just like before with auto model sequence classification. And then we are, sorry, then we're, I got thrown out there. Basically give it some titles and get the text input, and then we're setting the height to 400. And then basically we are just doing a little bit of stuff here to add the button, and then had the negative or positive labels. They get this ST error or ST success, which just gives us the red or green labels there. And if you ran the code cell above, hopefully your app got deployed, and you could go to the app section, click on this HTTP endpoint area, and you should be able to open it. And then you have your running app. So did anyone get all the way through and actually not only fine-tune a model, not only build a production-grade pipeline, but also deploy your model inside of an application? And I'll pause here for any other questions too. And like I mentioned, if you thought that ST was interesting, check out the Flight 2 SDK we just talked about for the first time publicly yesterday. Alexander said not yet. Is it stuck somewhere? Is it still spinning up resources to deploy the model? Let me know. Let me know if there's something going on. So it said, definitely interesting. Got to try one my own pace. Oh, yeah, for sure. I know it can be a lot to go through, but you have all the code. So like you can go through all the code a little bit slower, run the code cells, pick it a little bit differently, add in your own code, try to bring your own models in. Obviously, that's the next step of learning more. Is like bringing your own models. Oh, Alexander said just finished. Let me check if it works. Let me know. Let's try another review while we're waiting. And again, this was just trained on 500 samples and a different type of data set. Let's see if there's, let me see if I can find one that's like a 3-star review or something that's a little bit harder to judge. Those were ones for the new Superman. Let's see what else came out. Fantastic Four. See with something a little bit more mixed ratings. Still pretty high. But let's see if I can find a, let's see, 3-star. This will be interesting because 3 stars is usually still positive, I think, right? Oh, you know what? This is interesting. Scary, traumatizing, 10 out of 10. But it's a 5-star review. This is a horror movie. So this might not be trained on horror movies too. That's actually really interesting. Let's see what happens. So this is pretty confident that it's a negative score, even though they say 10 out of 10 in there. So we probably don't have data in our model that has anything like that. It's really funny. It's a good example of, you need that variation of data. Yeah, that one's probably confusing even for pretty good models. Unless it had context of like it's a horror movie or something, right? Because if it just said scary, traumatizing, even without the 10 out of 10, this actually, I wonder if it goes up in confidence. No, but yeah, this would be hard probably for most models. Alexander said, neat, the app is deployed and working. Awesome, so you went through the whole thing. Again, you went through, trained a model, built a production grade pipeline, and have an app serving that model, which is really cool. I do got to wrap up the stream because I have some other meetings I actually have to run to. Usually I try to put a little bit more of a buffer time here to answer more questions, but I have to run today. If you have questions, though, join the Slack channel, post the link in the chat again. Say hello in there. Again, there's an introductions channel. Feel free to say hello there. And then also just if you have any questions about anything you see today or saw today, join there. And like if you try this on your own time, bringing your own models, if you get stuck, let us know in that channel. And there's other stuff too, like the AI book club I mentioned, we talk about there. So if you just want to join, hopefully a cool AI community, join that channel. And hopefully I'll talk to some of you all later. Like I said, I'm going to wrap up today. Normally I like to have a little bit more buffer time, but I will talk to hopefully some of you later. And feel free to connect with me on LinkedIn. All right, bye everyone.